we compare to the metallic structures. Okay, so there are the three, which is the first one is the BCC, body centered, F sense face centered, and hexagonal close packed. Okay, so atom present, as you can see, here is the number of atom present 2, here is a 4, and here I have not defined, but it is a, here the 6. Okay, I have already mentioned how they comes and how they contribute as a total 2 in BCC, and how the 4 comes out, and I have just left this one. So it is just remind in your mind that it has a total number of 6 atom present, though they have not changed their packing efficiency. Okay, as you can see, because why? Because in packing efficiency, the volume occupied, you can have you can have a doubt as, I mean, here is the 2 atoms, then this packing efficiency, here is the 4 atoms and only 74%, and here the 6 atoms, but still they have the 64%. Because you can think about, in FCC and BCC you have cubic like structures. So cubic like structure have the less volume, overall volume. And if we talk about the hexagonal pack, as they have, yeah, here, this one. So hexagonal pack have the more volume as well. So as you have increased the volume and you have increased the occupation both, then the ratio would be come out same. Okay, if only you are just occupying, the nature is increasing, I mean the number of atoms is increasing, and the overall volume is constant, then you would have the compare. Okay, but in FCC, as in case of the BCC and FCC, they have the common volume. Okay, which is A is equal to volume is equal to A cube. Okay, in case of the cubic nature. Okay, but in case of the HCP, you have the higher volume, as you can see. This is your HPC. Now we talk about this one. So this one is your cube. As you can see, the cube has a less volume. Okay. If we talk about this, suppose this length is same. This length and this length is same. I mean, the value of A means the length of the edge. Okay, either in cube or in hexagonal, both have the same length. Still, the hexagonal would have the higher uh, volume, okay, as compared to the cubic volume. Okay, that's why if you have the same volume, then you can have a idea to compare. But in case of the cubic and hexagonal have the higher volume. So higher volume and higher occupations, they the ratio of these two is known as your, I mean, the total volume present a denominator and the number of the volume occupied by the atom at the numerator. That basically gives you the packing efficiency. So in case of the hexagonal, you have increased the number of atoms as well at the numerator, which is 4 to 6, right? But at the same time, you have increased the volume as well. That's why you're having the same kind of packing efficiency. So don't get confused about that, why both have the same 74%. They, though they have the different kind of the atom, different number of atoms are present, because the volume in FCC are also increasing. Okay, that's why you are having the same kind of packing efficiency. So don't get confused in that. Okay, now we talk about the coordination numbers. Then yeah, it's a very clear. It's in the coordination numbers of BCC there is a 8, and in FCC there are 12. And if we talk about the HPC, they are the 12. Okay, F, as we have discussed, at above, the ductility. In the case of the BCC moderate, FCC is higher, and in a HPC this is moderate as well. Okay, so keep in mind and could have your idea and what the kind of the material that show the FCC, BCC, and HCC. So these are the just the crystal structures. Okay.